So I just wanted to do a little blurb on timing relays. Timing relays are called relays because there's two parts to the operation. We've got to have a timer coil and timed contacts. So the coil is the brains of the operation. This is where the timing happens, and it will either time on energization or on de-energization. You'll notice here I have a little table with two categories. So we have a delay on timer and a delay off timer, and all that means is that the coil is going to behave differently depending on what's activating it. So the coil here, I have controlled in this little circuit beside me here, I have controlled by just a simple on-off switch. This on-off switch is going to energize the coil, and if we want to talk about delay on timers first, as soon as this switch closes and the coil is energized, that's when the timing starts. The contacts that are controlled by the timing coil don't change states until the timer has timed down. So we're going to close this switch, we're going to energize this coil, and after so many seconds or minutes or whatever duration of time you have it set for, after that is elapsed and timed down, the contacts controlled by that coil are going to change states, and the light is either going to, well, in this case it's a normally closed contact, so the light was on, and after the timer has timed down, the contact is going to open, shutting the light off. So I just think it's really valuable to talk about the symbols of the contacts for a second, because that's the next most complicated part about these timers. So on a delay on timing system, I've put a little helping little note here for me. I've got an arrow up, because the symbol for a delay on timer should always be pointing up. The other thing to note about delay on timers is we're changing the state of that timer from its normal state. It's going to undergo a time. Once the time counts down, it's going to change states to the opposite of its normal state. So this normally closed contact here, after the time down, is going to time to open. The normally open timer, after the countdown, the coil is going to tell the contact to close. So I have to make sure that I'm drawing these symbols pretty carefully. Like I said, delay on timers, the arrow on the symbol for the contact has to be pointing up. If that's the case and we're changing states from normally closed to open, we have to figure out how to orient the contacts in such a way that if this contact times and pushes up, because the arrow points up, I'm going to change the contact from closed to open. So that's the important thing. That's why I've made the connection on this moving part of this timer contact to be on the top side of the terminal, so that after the timer counts down, it opens up. On the normally open time to close timer, I've had to draw the toggle, or the moving part of the timing contact, below the contact point in the rest of the circuit, so that when the timer runs out, the arrow is pointing up. Remember, as the timer runs out, I'm closing this contact, changing from normally open to closed. So let's swap over to delay off timers now, because that's the next thing. Delay off timers work almost the same, except they start timing when the coil is de-energized. So let's go back to our circuit here and talk about this for a minute. I'm going to erase that symbol because that was delay on. We want delay off. There we go. Don't forget to reference your contacts. So in this circuit, I'm going to close my switch and energize my timing relay. Delay off timers time on de-energization. So on energization, the contacts change immediately. They're instantaneous. So I'm going to energize my coil. This normally closed contact is going to pop open upwards, and it has to be upwards, so that on de-energization of this coil, I'm going to open this mechanical switch, I'm going to de-energize that coil. Now the timer starts, we start counting down. Once the countdown takes place and is finished, these contacts change to the normal state, downward now, because delay off timers their symbols have to point down. So our contact is at the top. When it's open, it's opened up. After the countdown is finished, we drop down to the normal state again, right? The changed state, or the timed state, has to match the normal state because it's returning back to that normal state. So we have this contact being, this delay off contact, as a normally closed, time to close. We could also have a normally open, time to open. In that case, the contact has to be made down below, opened down below, so that on instantly upon energization of the coil, this contact is going to push up and close. We're going to de-energize the coil, wait for the countdown to happen, the timing to happen, and once that happens, we're going to drop down, because the arrow points down, we're going to drop down open to its normal state again. Once you know those concepts, you can use these these timing relays for a huge variety of applications. I've seen them in public bathrooms, processing plants, in facilities, manufacturing, and motor control circuits. So you can use them anywhere. Have fun.